Hello everybody and welcome to our last section for chapter 6, and this is on the general form of a linear equation. So far we've looked at slope point form and slope intercept form, and this is the last one that we're going to study in this course. And it's kind of the least useful in a lot of ways, the general form. But what is a useful skill is knowing how to change an equation from general form back into slope-intercept form, because that's our most commonly used form. But there's a few neat things about general form, so that's what we're going to talk about today. So general form of a linear equation is when your equation can be written in the form ax plus by plus c equals 0. So you can set it equal to 0. So that's an important feature. And a is a whole number, which actually means that a also has to be not 0, not a fraction, and it has to be positive. Okay, and b and c are integers, so not fractions and decimals, but they could be negative. Okay, so we're always going to try and write it so that our x is first, then our y term, then our constant term, then equals 0, and we want to make sure that we start with a positive and no fractions or decimals. Okay, so the best way to learn about general form is to work with some examples. So here's example 1, rewriting an equation into general form. So this is currently in slope-intercept form. We can see the slope of -2/3. We can see the y-intercept of 4. But what we want to do is write it in general form. So the first thing that's probably bothering us is this fraction. So I want to get rid of this fraction. I'm going to multiply my entire equation, both sides, by 3. So that means every term is going to be multiplied by 3, and that will allow us to rewrite this term as a non-fraction. So 3 times y is 3y. 3 divided by 3, so these 3's cancel, and we're just left with -2x. And then we have 4 times 3, which is 12. So we've gotten rid of the no fractions, or got rid of the fractions, which is great. Now we have to get it in the right order. So I want to have my x first, and then my y, and then my constant term. So if I move the 3y over by subtracting 3y from each side, then I'm going to have on my next step 0 equals -2x minus 3y plus 12. So we're almost in standard form. We've got the x, then the y, then the constant. The only problem is we have a negative as our a value. It's -2. That's what's in front of the x, and I don't want that to be negative. So I'm going to divide each side of my equation by -1, and that will change it to a positive 2x. Now we also have a positive 3y, but we have a -12. So this is now in general form because it's got a positive. We're in the order x, y, constant, and we have one side set equal to 0. We also have no fractions. Okay, so let's try the same thing here for b. So you have to ask yourself, what would we want to multiply everything by this time to get rid of that fraction of 3/5? Well, this time the denominator is 5, so we're going to multiply by 5. Just watch out. On the left side, you have 2 terms, and on the right side, we actually only have 1 term. Because this is being multiplied to this all counts as 1 term. So our next step would be written as 5y minus 5 equals, the 5's cancel here, so we get 3 sets of x plus 2. Now I want to get rid of my brackets, so I'm going to distribute that 3. So I get 5y minus 5 equals 3x plus 6. Now I'm going to set a side equal to 0. I'm going to learn from what happened last time. I want to keep my x term positive. The 3 is already positive, so I'm going to keep all of my terms on the right and set the left side to 0, which means I need to get rid of the 5y. So I'm going to subtract 5y from each side, and I'm also going to add 5 to each side. Actually, I'm going to show where I'm going to add that 5 to be, it's going to end up combining with the 6. So these cancel out. I have 0 on the left. I have 3x minus 5y plus 11. I just kind of changed the order around there to make sure it's in my x, y constant order. So the general form of that equation is 0 equals 3x minus 5y plus 11. Example 2 demonstrates one of the more useful aspects of general form, which is that it can often be easier to find intercepts. So we're going to start by determining the x and y intercept of that equation. So just a little reminder, when you want to find the y-intercept, you set x equal to 0 because it would be somewhere along the y-axis, which means it has an x-coordinate of 0. Okay, and when we find the x-intercept in a moment here, we're going to set y equal to 0. Okay, so we'll do each of these separately. So first we're going to find the y-intercept. So I'm going to set x equal to 0. So I have 3 times 0 plus 2y minus 18 equals 0. So I just rewrote my equation, but I substituted in 0 for the x. That now leaves me with 2y minus 18 equals 0 because, of course, 3 times 0 is 0. There's no point writing that. And I'm going to add 18 to each side. And that gives me 2y is equal to 18. Now I'm going to divide each side by 2 to get the y by itself. And I end up with y equals 9. So what that's telling me is that my y-intercept is 9. Now I'm going to find the x-intercept. So I'm going to set y equal to 0. And so that becomes 3x minus 18 is equal to 0. And I'm going to add 18 to each side. It's looking kind of similar to what I did last time. And then I'm going to divide each side by 3. So I end up with x is equal to 6. 1, 2, 3, 4, 5, 6. So there's my x-intercept. Now 2 points is enough information to draw a line. So I'm going to go ahead and draw my line. I'm going to put arrows on either end. I'm going to make it blue. What the heck, just to match what I had here. I'm going to do the neatest job I can to draw that line. So a couple things to note about the line. Of course, it goes through both intercepts, and I have arrows on each side showing that it can go on forever. So that is part B. And if you don't have a ruler, you can always just use anything straight, a cell phone, a calculator. I was using a stack of Post-it notes, whatever you happen to have handy. Now C, to verify that this graph is correct, what we're going to do is use a concept from a previous section. We're going to think about putting our equation into y equals mx plus b form, and then we can check to see if our slope and intercept match what's on our graph. So I'm going to take that 3x plus 2y minus 18 equals 0 and try and put it into that format. So I'm going to try and isolate my y. So I'm going to subtract 3x and add 18 to each side. Here's kind of my two sides of my equation. So now I'm going to have 2y equals negative 3x plus 18 because these canceled out. I did the opposite so that I could move them. Now I'm going to divide each side by 2. So here's where you have to be careful. You're dividing both terms on the right by 2. So we're going to get negative 3 over 2x plus 9 because 18 divided by 2 is 9. So here's my new equation. It's telling me that the y-intercept is 9 and that the slope is negative 3 over 2. So let's check both of those pieces of information. Back to our graph here. Is my y-intercept 9? Yes, it is. And is my slope negative 3 over 2? Well, if I start at this point and I go down 3 and over 2, am I still on my line? Yeah. If I go down 3 and over 2, I'm still on my line. So it is, in fact, the correct slope and the correct intercept. All right, so that is one way that we can verify that our graph is correct. Example 3, this is our last set of examples here. It's probably the skill that I would say is the most useful when you go on to future math classes, and that is taking a line that may be in general form right now and changing it into y equals mx plus b form, just like we did in that last example. Why? Because this is a little bit difficult to graph. Y equals mx plus b form is our preferred method for graphing, or preferred format for graphing. Okay, so I'm going to start by trying to get my y term by itself. So I'm going to subtract 3x and add 16 to both sides. Okay, so that allows me to have negative 2y on the left and negative 3x plus 16 on the right. I want to have just a single positive y by itself, so I'm going to divide each side by negative 2. And that leaves me with y equals, well, negative 3 over negative 2. A negative divided by my negative becomes positive again. And positive 16 divided by 2 is -8. So there is our final equation. I'm just going to leave a little bit more room here because it did ask us in particular to identify the slope of the line and rewrite it. So there's our rewrite and there's our slope. And it's pretty much the same thing for the rest of these examples. They're all quite similar. And so let's take a look at another one together here. So I want to get the 2y or the -2y by itself. So I'm going to subtract 5x and I'm going to end up subtracting 12 from each side. So that leaves me with -2y equals -5x minus 12. Now I'm going to divide each side by -2. And I end up with y equals positive 5 over 2x plus 6. So negative divided by negative gives us a positive fraction here. -12 divided by -2 is where we get the positive 6 from. And our slope is just going to be our m value. So it is 5 over 2. Now is a good time if you want to pause and try the next couple examples yourself. See if you can do them yourself. They're very similar. So feel free to pause the video here if you want to try some on your own. And then you can unpause it to see what we did. Okay, so we're going to, again, isolate our y. So I have a positive x, so I'm going to subtract x from each side, and my positive 9 means I'm going to subtract 9 from each side. And whatever I do to the left side of my equation, there's kind of like an invisible line here. I got to do the same thing to the right side to keep my scale or equality balanced. So now I have 3y on the left, that's equal to -x minus 9. Now I'm going to divide each side by 3. So I end up with y equals, well, -1 divided by 3 is going to be -1/3 x. -9 divided by 3 is going to be -3. So there's our equation, and our slope here is going to be -1/3. On our next one here, I'm going to subtract 20x and add 50 to each side. That leaves me with 10y is equal to -20x plus 50. Obviously, I need to get rid of this 10. So I end up with y equals -2x plus 5. So the slope here is -2. No need to write -2 over 1. -2 is fine. Last two examples here. I'm going to start E by adding 5x and subtracting 12 to each side. I end up with 2y equals 5x minus 12. I'm going to divide each side by 2. Y equals 5 over 2x minus 6. Oh, and I forgot to state the slope. Slope is 5 over 2. Last one. Add 2x and add 27 to each side. We end up with -3y equals 2x plus 27. Divide each side by -3. So y equals -2/3 x minus 9. And our slope is -2/3. That takes us to the end of chapter 6. Okay, so that is the last part of this video. I will post another short video just reviewing a little bit of the difference between the 3 types of equations and the 3 types of forms there, just to kind of clarify. But otherwise, thanks for tuning in. Good luck with your assignment now. And as always, please let me know if you have any questions. I'm here to help. Okay, have a great day. Thanks.